Looks like we've already mastered this fractions of different wholes, probably from 3rd grade. So let's move on to the dreaded common denominators. Now, common denominators is like a horror story for so many students, and it's easy to see why. And there are a lot of really kind of silly rules that we kind of throw at students and have them memorize and repeat over and over again. And a lot of those rules only make sense in a very narrow context. For example, we may at some point be talking about the least common denominator or the least common multiple here, but in general, I don't care about least common multiples or least common denominators. If you find a common denominator, a common multiple that is correct, then it'll work. If it's not the lowest, it just means that you're going to have to do some simplifying later, and that's okay. So let's jump into common denominators and see if we can break this down a little bit so that we can understand what we're doing. The trick is, we've already been doing it. For the past 2 videos, we've already been talking about common denominators. We just didn't call them that. We've been talking about breaking down small fractions into smaller fractions, thereby multiplying how many of them there are. Here we go. We have 2 fractions, 5/8 and 5/4, and we want to rewrite them so that they have a common denominator and whole number numerators. What numbers could we use for a denominator? Now, I really like this problem. Back up just a little bit. I really like this problem because it is acknowledging that there are many possible common denominators. Now, let's do a really quick definition. When I say common multiple, a little bit too big. When I say a common multiple, what I mean is exactly that, a number that is a multiple of both. So in this case, we have 2, and by the way, you'll notice that I say common multiple instead of common denominator. But these are equivalent statements. When you are looking for a common denominator, you are looking for a common multiple. So I will be using the 2 words kind of interchangeably to get you used to it. But again, to be clear, common denominator only works when you are talking about the denominator of a fraction. Yes? So I tend to use the word multiple more often. Anyway, for example, if I have 4 and 5, yeah? And I wanted to list out the multiples of each. Well, 4, then is 8, then is 12, then it's 16, 20, 24, and we're running out of space here. If I was to count multiples of 5, I would get 5, 10, 15, 20, 25, etc. Yeah? Here, I'll duck down a little bit. There we go. So a common multiple is anything that is common, that is the same between these 2 lists. In this case, 20. And it just so happens to be the least common multiple, the lowest common multiple, because it's the first one on the list. It is not the only common multiple, however. There are infinitely many more, and that's what we're talking about here. So, when we are looking for common multiples, we are looking for essentially a number that is divisible by both of the base numbers. Yeah, we've done this before. We did it a lot several videos ago. Let's see what we can do. I'm gonna erase all of that, readjust my seat. Okay. So let's just go ahead and start by listing out multiples here, okay? So we've got 4 and we've got 8, yeah? I'm just going to start listing out multiples until we get more than any of these numbers, okay? So we already did this one. It was 4, Actually, I already have 4 there. 8, 12, 16, 20, and that's as high as any of the numbers that we've got here, yeah? 8, 16, 24, 32, and again, that's higher than anything there. So, what common multiples do we have? Well, I certainly see that we have 16 and 16. Whoops. There we go. 16 and 16, but there is another one that's even lower. This 8 and this 8. Yes, the initial 8 still counts as a multiple of 8. Yes, it's 8 times 1, so it is a multiple of 8. The lowest common denominator, the lowest common multiple here is 8, but 16 is also a correct common multiple. Now, I'd challenge you to pause the video really quick and see if you can come up with another 1 or 2 common multiples that are going to be bigger than these two, but would still work as common denominators in fractions if you needed them to. In the meantime, we can use 8, we can use 16, we cannot use 4, because 4 is not a multiple of 8, it is a factor of 8. Go back to my videos on multiples and factors if you need a refresher there. And 20 is a multiple of 4, but not a multiple of 8. Well done, moving on. List the first 5 multiples of the denominator in each fraction in order of least to greatest. So this is exactly what we just did, right? It's just asking us to list out multiples until we find ones that are common. So 6, 12, 18, 24, and 30. Really, this is feeling a lot like some of the second grade videos that we did where we were just sort of skip counting a lot to get a feel for multiplication. Again, I really want to connect these ideas right here back to those kindergarten, first and second grade ideas so that students know they're not learning anything brand new. They're just learning different names for the stuff they already know. And then I'm counting by tens, so 10, 20, 30, 40, and 50. So the least common denominator between these two, it looks to me, is 30. Yeah, the lowest number that's the same between each one is 30. Now, I anticipate a particular question here. I know some student, if I had this assignment out, some student would raise their hand and ask me this very, very good question. Well, wait a second, what about this 2 here? And what about this 7 here? What do those mean? What do they mean in the purposes of this problem, or in the context of this problem? What do those numbers mean? And the answer is nothing. This would be as part of maybe adding 2 6 plus 7 over 10. We could find a common denominator and then be able to count them all together because they'll all be the same size. They'll all be the same denomination. But that is not a part of this problem. However, it's important that they're there because students need to get used to the idea, A, that sometimes problems are going to have information that they don't strictly need, and B, that they're going to be using this technique that they're learning right now in solving fraction problems later on. Okay, the least common denominator looks to me to be 30. Up next, rewrite each fraction with a denominator of 12. So this is kind of a throwback to the last video. We talked about this a little bit. We want to know how many twelfths are there, and we kind of sort of came to the conclusion that it has to do with multiplication. We sort of know that anything divided by itself is 1. We sort of know that if we triple the number of pieces, then each piece has to be a third as big. We're still fitting these ideas together, and when we start talking more about multiplying fractions, then it's really all going to come together. So 3/4 is the same thing as 9 over 12. You have to triple the number of pieces to get from 4 pieces to 12 pieces. So if we triple the number of pieces, then we triple the number of pieces? How does that make sense? We're taking each piece and tripling it, right? Cutting it into thirds, which means that there is 3 times as many, and we're taking 3 times as many. So if there's a cake cut into fourths and we take 3 of them, that is the same as that same cake being cut into 12 and us taking 9 of them. 5/3 is the same thing as 20 over 12. And again, I really want to highlight how amazing it is that Khan Academy takes on the idea that you can have a larger denominator or a larger numerator than denominator. That's okay. There is nothing improper about it. We have 2 fractions, 2/5 and 3/10, and we want to rewrite them so that they have a common denominator. What numbers could we use for the denominator? Now here, I see 10 immediately as the denominator because 10 is a multiple of 5. When one denominator is a multiple of the other, it makes the lowest common denominator a whole lot easier to find. So 10 is definitely one of them. But it's not the only one. If we list out the multiples of 5 and 10, 5, 10, 15, 20, 25, 30, and then we list out the multiples of 10, 10, 20, 30, 40, 50, 60, you'll find that we're going to get lots and lots and lots of multiples that work. Yeah? 10 is in both of those, 20 is in both of those, 30 is in both of those, and again, it turns out that every single multiple of 10, because 5 is a factor of 10, every single multiple of 10 will work as a common denominator. We could use 10, 20, 30, 40, 50, 60, any multiple of 10 that we wanted. All of them would work. So 10 and 20. And that is our first sort of dipping our toe into the pool of common denominators. Stay with me. We're going to keep going from here.